Good evening, everyone. Welcome to the latest in our inaugural lecture series. A particular welcome for making it out on such a cold evening, but also a specific welcome to the friends and family of our lecturer this evening. I always say on such occasions, these lectures can be very, very difficult because of the diversity of the audience, where you've literally got world-leading experts sitting in the audience, as well as people who probably haven't a clue what the title means yet. But nevertheless, that's part of the challenge of an inaugural lecture, and actually part of the enjoyment of an inaugural lecture when it's finished. Before it starts, it's a little bit more pressure. This evening, though, is a little bit different because Dave Healey is one of our new professors of practice. He's the professor of practice for the Smart Energy Network Demonstrator, the SEND project. And the concept of a professor of practice is one that's been around in the US for some time. It's taken off in the UK much more. It's certainly a relatively new entity for us. But it is a way of recognising a contribution of new people linked into the university who have a slightly different background from the normal people that we have in inaugural lectures, in that they're bringing a great experience and international and national status that is often from the world of business or another sector rather than from within the universities. And that is especially important for our SEND project because, as many of you will know, that is a project which now really is taking off. There's £30 million worth of investment going into this campus in different ways in terms of the infrastructure. And in the end, it will actually turn this campus into a very unique research facility that will not only benefit the basic research that we have here at Keele, but really promises to make a significant difference to exactly the question that we're going to hear about this evening, about the general issues of climate change, energy, sustainability, and how we might all use that and change the way we do things and change the way we get our energy in order to have a sustainable future for ourselves and indeed for future generations. So Dave works for us in the university part-time. As alongside that, he's presently heads the Smart Energy City practice at the international consultancy group Analysis Mason. And his latest projects, or more recent projects, for example, have been a 12-month study on global smart meters and solutions and projects on behalf of the UK Future Energy Systems Catapult. And that, again, is around encouraging industry to make a transition into different energy usage. Dave's career in the energy ICT sector actually began in the 1990s, and he had a founding role in two of the first major power utility diversifications into commercial telecommunications, at Norweb and also at National Grid. He's subsequently been invited to develop similar sort of strategies around the world, and there's quite a long list of different countries here that he's worked in. But he's also worked more broadly right across the utility and telecommunications sectors, and including with some of the really big companies such as Cisco and Nokia and Siemens and many, many others. So Dave brings a very special and slightly different perspective to the academic endeavours of Keele. It's a great pleasure to welcome him this evening, and I'd like to invite him to give his inaugural lecture, The Digital Energy Revolution, Can It Save Our Climate from the Precipice? Dave.
Good evening, everyone. Thank you so much for making the effort to be here on such a poor evening in terms of weather and temperature. And also, for those who I've shaken hands with, I do apologise. I hope I've not passed on my lurgy, and I hope my voice will keep going until the end of the presentation. So, thank you, Vice-Chancellor, for those kind words. I must say, I've presented in probably most corners of the world over the last 25, 30 years. in many different environments and situations and with many different audiences. And as some of my colleagues will tell you, this is the first time I've been nervous about presenting on a platform such as this. And I was wondering about the reason why. First and foremostly, it's because my family's here. They've only heard about what I do third hand up until now. So now they get to judge me first hand, which is a bit worrying. But then secondly, of course, the room's full of people from different aspects of the university who are all experts in their own field. And I hope I'm up to the task and can inform them and the audience as a whole, and also hopefully find this a little bit entertaining. So I know the weather is supposed to get a little bit worse later on this evening, so I'm not going to hang around. And in fact, I've probably got more slides than I'm actually going to speak to. I may flick through a few of these slides just for expediency's sake. But what I want to do is make sure that at the end of the presentation you have a feeling for the optimism and the excitement that I have about not just what we're doing here on SEND, but on the wider international agenda of battling climate change. Okay, so let's make a start. I would like to thank, by the way, a number of people, and I'm going to leave that until the end, if I may, because this particular position of Professor in Practice for me was a huge honour. Unexpected for sure, but something that I've really come to love in terms of the opportunity that it's offered to me. So I do feel very humbled and honoured to be here, and I do want to thank a lot of people, some who aren't even here tonight, but I will come to that at the end. Okay, introductions. I don't need to introduce myself any further, I don't think, but what I do need to say is my role at Keele is part-time, as the Vice-Chancellor mentioned. I do have a day job, which is quite extensive in its brief, but I think complements what we're doing here at Keele very much so, in that I'm engaging with industry, regulators, governments on this agenda, and I think will help inform how we take SEND forward, and also the wider sustainability agenda for the university, which I think is huge, potentially huge, sorry. So the agenda I want to address tonight, firstly climate change. I'm not going to go into the detail of the whys and the wherefores, I'm just going to make some very blunt statements. And then to talk about how we actually started off on our journey of making our energy systems sustainable and decarbonising them. Moving on to then how digitalisation is now accelerating that process in offering us real opportunities to embrace decarbonisation. And then come on to Keele in particular, and how that, what an important role it can play, I think, in this decarbonisation agenda. And then finally, where are we, and what's the answer to the question that I posed as the title of the actual lecture. This is me. Again, I'm not going to mention any more details other than the UN role that I hold, I think was really the eye-opener for me in relation to the importance of understanding how urgent our actions on climate change are. Here's some worthwhile reading, and there's lots more. I wanted to put this slide up really to say, after this lecture in weeks, months to come, please reach out to me if you have any questions, any issues at all. My role here, I would like to think, is as much a communicator of the agenda in SEND and Keele as a whole as anything else. So please feel free to contact me, and if I can help in any way or provide information, I will. So climate change. I work part-time as an advisor to the UNECE. It's one of 3 regions in the UN. It happens to be the one that represents all the major economic powers, Russia, the US, Europe. It's just simply divided by geography. And it goes back to the original implementation of the UN. But what it has done is allowed me to meet and discuss the issue of climate change, not just with scientists, but with government officials, with representatives of major industrial companies, all who have the same view and the same objectives in mind. How can we turn our economy and the way we live into a more sustainable one in order to ensure that the opportunities for our children in years to come will be those, will not be inhibited, which could well be the case if we don't take prompt action. And core, and the theme of what we're talking about this evening, is how do we turn our energy system into a sustainable one? How do we decarbonise the whole value chain? And how can we ensure that the vested interests that so far have been battling against the action we want to take on climate change, how can we turn that around, turn those interests around? There is more than sufficient renewable energy available to us in a single day to power our existing and future energy needs, whether it's solar energy or wind. The UK is one of, if not the most windiest countries on the planet, and that gives us a huge opportunity, and one that we're beginning to address and realise, but one that we've not really embraced fully so far. But it's the decarbonisation of energy and transport which will really define whether we win our battle against climate change. There's many, many other aspects to that battle, and many more sectors of society that need to take direct action. But if we don't decarbonise our energy value chain and the transport value chain, then all will be lost. And that's where I've been focusing my attention now for the last 10 years or so. Now, I knew that would draw gasps, okay? I knew where the gasps would come from, but I am not making any apologies, okay? I will pay for this later, by the way. The reason I put this picture up is there's 2 reasons, okay? What I cannot understand, and I struggle, and I've had meetings with major oil companies and others, that when they're presented with the evidence and we realise how huge the impact of climate change could be in 20 or 30 years' time, it's the children, our families, who will suffer, okay? I will be long gone, but it will be those people who will suffer. Why? I really cannot understand why they do not accept that their actions will not impact their families directly. If anything was going to impact my family directly, whether it's climate change or something else, I would obviously take direct action. So that's what I struggle with. And this is a bit more, so that's brought smiles to their faces now. This is the more up-to-date picture. It did turn out all right in the end. And Hattie, who is the young lady on your right, couldn't be here tonight. There was a chance she was going to put in an appearance, but anyway. But she's our first grandchild, and I'm very pleased to say that. So that's the reason. Those are the reasons why we need to do something now. It's not next year or the year after. Every year now that we do not accelerate our action against climate change is going to impact our children and our children's children, and to an extent that we really cannot accept. Okay, now I'm going to play a short video simply because this gentleman here, who's not a member of my family, but I've got to say he's one of the few politicians that I hold in high regard. summarises, I think, the issue very, very well.
On climate change. Now, if you went to a doctor, no, let's change that. You go to 100 doctors, and 99 of them tell you, you've got diabetes. You've got to stop eating bacon and donuts every day. And we have to monitor your health, and we got to fix this. You wouldn't say, oh, that's a conspiracy. They're making that up. All 99 of those doctors got together with Obama to try to prevent me from having bacon and donuts. You wouldn't do that. That's not what you do. There's not a single person who would do that. I mean, it'd be funny, but except this is about climate change. This was an analogy. And the planet's warming. 99% of scientists have said it's warming, and we've got the Republican chairman of the Senate Energy and Environment Committee carrying a snowball into the Senate chambers to show that there's still snow and that climate change isn't happening. I am not making that up. That's what happened. That's what happened. That's crazy. I was going to quote Kanye, but I can't because there's a family audience. But it's cray.
Okay, so the other reason that I played that video was that COP21, which was the turning point in terms of the UN's fight against climate change, where finally 195 countries all agreed to take direct action on climate change. It was that guy's, it was down to him. A huge, if not almost all of it, was down to him. The last day of the discussions and debate, there was a meeting of, I think there's 12 different countries who all were going to disagree and not sign the accord. And Obama heard about this and basically walked out of a staff meeting that he had, walked directly through the UN building where the meeting was taking place, walked into the meeting unannounced and uninvited and turned the meeting around. And by the end of that day, we had 195 countries in agreement. Now, politics is politics, but you have to give the man some respect for the fact that he put everything on the line, his political agenda, and really turned the whole meeting, 2 weeks of meetings around in the final few hours. Now, if you read some of these links, and in particular David Wallace's book, they paint the darkest picture of where we may go with climate change if action is not taken sufficiently quickly. I'm not saying you should read that, but what I'm saying is if you want to really understand how close we are to the precipice, then there's some reading that I would recommend. Okay. So what can we do? Basically, power systems have been have changed very little now for almost 100 years. They were built in the same manner that they've been operated now up till, well, let's say roughly the turn of the century. Basically, single directional energy distribution from centralised power plants to your devices in the home, to your meter, and to large industrial and commercial customers. Nothing has changed, or very little, over that period of time. And most companies have basically relied on how they've managed those networks on projecting how those networks have been run and how they've performed over those years. Little has been done to enhance their quality of service. And during that period, We've had coal fires. We've had the advent of Energy 7, for those people who remember that, which was the first really testing of a demand response application. We've had telephones. I remember my first telephone in the early 70s, I think it was, and we shared it with the next door neighbour. And it was, you could make a call if he wasn't using it first. So the point I'm trying to make here, technologies have moved on and moved on in parallel, but electricity systems haven't. And this is a typical power system. This is a power company in Spain called Iberdrola, and they distribute to about 10 million customers. But basically, they have tens of thousands of substations at the ends of the street that supply about 100 customers, and there's a hierarchy of substations throughout that network. Again, that has not changed for 75 years or more. Does anyone know where that is? You all know where that is. Does anyone know when it was? Stick your hand up if you know. No? Yeah, I bet some of you do. 2003, New York, big blackout. Do you remember? Basically, the whole of the northeastern seaboard of the US went dark. And they lost electricity supply to about 50 million people. And it was basically the result of one thing and one thing alone. They'd been running that system as they'd been running it for 75 and 80 years. And eventually something went pop. Now, there's lots of different reasons that people have given, but that's the underlying reason. And it was that particular occurrence that galvanized the US, and as a result, global energy companies, to really say, okay, things have got to change. There've been talk and discussions, and I've been involved in them many years before, about how we can improve energy systems to make them more reliable. But that's what really kicked things off. And then we started to talk about controlling energy networks from end to end, whereas before, really, all we'd monitored was how the high voltage networks worked, because the rest of it didn't really matter. It got there in the end. But still, the rationale for making the grids intelligent at this time in the early 2000s was other things. It was people who wanted to address the issue of energy security. They wanted to find other means of supplying energy in the US in particular, and the move to shale gas was one of those things that happened as a result. But also, it was an economic stimulus. They wanted to invest in power systems to try and stimulate the economies of the Western world, especially after 2007, where they took direct action to invest in power systems to try and counter the effects. But all that resulted in a huge amount of change taking place in power networks and power utilities. And change, as we all know, in even the simplest things, can be very difficult. Here's just a few. I mean, there's lots of these quotes on the... And in fact, if you look at the one from Bill Gates, if you go on Bill Gates' website, he denies he said that. He purports that it was one of his staff. But anyway, whoever said it, I like the one at the bottom. Especially now, because IBM's AI system that they're devising, they've called it Watson. But yeah, so change is very difficult, and projecting where technology goes in particular is always very difficult. But for 7,500 years, these companies had not changed. These energy companies had not changed, and now they're having to change almost on 180 degrees. And what made it even worse for them at that time, telecoms, was the rationale. They had to introduce data systems into their networks, over large parts of their networks for the very first time. And telecoms was advancing so quickly through the 90s and the early 2000, and is doing still, that the utilities trying to embrace that technological change, and I was there, was so hugely difficult, and they really didn't do very well at it. The first steps were smart metering. And smart metering was came out of Obama's objective of trying to counteract the results of the financial crash. And Europe followed. Although, in fact, Italy started to implement smart metering even before the US did. But $3.2 billion was invested in rolling out smart metering in the States. The major advantage to the energy companies was that they, for the first time, had real data about how the customers were using their product, energy, electricity. And this was my attempt in 2007 to embrace what that would mean for the energy companies. This was my own. It's quite nice, that really, isn't it? I didn't do that. I drew it on a piece of paper with a pencil, and someone else made it look very nice. But what that is saying basically is that for the first time, instead of relying on a big power station a few miles away outside the city to generate electricity and push it down the networks down into every consumer's premise, for the first time we could look at distributed generation. And this is the theme, really, of what smart grids and smart energy is all about. And now, this could take... I'm going to give myself 30 seconds on this slide, because otherwise, as some of my colleagues know, I'll be talking on this slide for the next 3 hours. Okay? But we have spent, probably, it will be nearer to 20 billion by the time this has been completed. Okay? We're deploying a technology that is so limited in its capabilities in terms of what we need to do now moving forward on smart energy as a whole, as I cannot even begin. Okay? And it was primarily the result of political expediency and the need to ensure that we still pursue these liberal economics of competitive dynamics being the saviour of everything. And we put into place technology which today is delivering very limited value to the consumer and to the energy system overall, especially when you compare it with companies like Iberdrola in Spain, as I mentioned earlier, who've deployed a system that is half, and don't quote me, but it's of an order of magnitude of half the cost and much greater value to the economy and society as a whole. I did well, honestly. I wasn't going to have that slide up, but anyway, I got past it. Thank you. So, very underinvested energy systems, very inadequate energy systems in the early 2000s, mid-2000s, to address what we need to look at in terms of decarbonisation of energy if we're going to address climate change in the way I've described. Now we have some new tools, and digitalisation and IoT, the Internet of Things, has started to identify to us new opportunities of how we can make our energy systems much more reactive, much more diverse, and offering us distributed generation opportunities that will help us decarbonise the whole value chain. COP21, I've mentioned this, but if you look at the comment regarding the meeting in Bonn a few weeks ago, all is not well. We had the agreement of 195 countries, but we have no hard policy commitments from countries that they will do X, Y, and Z. There are some projections on goals and objectives, but in terms of legally binding commitments, there is very little. And climate scientists are saying now that we must look to a time of peak oil in the very near future, and we must then reduce our carbon emissions by half every year. I mean, it's easily said, but it's staggering what that actually means. So the time is now. This is when we have to make our decisions. And unfortunately, we're still fighting these vested interests. For years, the last few years, we've been hearing renewables cannot maintain our energy supply because they're only available at certain times of the day or when the wind's blowing. Well, that is not the case, because people are deploying renewable energy with storage to address that issue, and have been doing for some time. We'll come on to that in a moment. And then we talk about things like carbon capture, which is generating carbon, but then storing it somewhere so it doesn't get into the atmosphere. Don't produce the carbon. There's lots of options available to us to ensure we don't need to do that. But ultimately, it's decarbonisation of energy that will allow us to then decarbonise our cities and reduce pollution in our cities. Arnie Schwarzenegger, of all people, Senator for California, took on Trump not so long ago, a couple of years ago I think it was, or last year, by saying, why would you not fight climate change just to address the issues around pollution? In particular, in LA, they have a huge problem there. I think his quote is something along the lines of, well, if he doesn't think, Trump, that pollution and climate change are a problem, sit in a garage, turn the diesel car on, seal the doors, and see how long it is before he changes his mind. And that is the same. It's the same issue. If you look at, in the UK, and we're not the worst in terms of polluting our cities with vehicle emissions, but we're now in the third iteration of trying to come up with a policy that will satisfy the courts in terms of how we're going to address pollution in our cities from vehicles. 3 times the government has been taken to court and been found wanting. Now, I know if I'm caught speeding on the highway once, I might get a fine. 3 times, they're not going to let me off the 3rd time. But action needs to be taken. IoT deployed for smart energy can also facilitate digitalisation of other utility infrastructures in cities, water, major buildings becoming energy efficient. It's not just the networks themselves. So that investment can be reused. And in Ireland, in fact, they're looking to deploy smart grids and smart meter systems, but they're looking at how those investments can also be exploited across city infrastructures in a way that will give them the biggest bang for the buck in terms of decarbonisation. And in particular, of course, if you're going to make electricity systems intelligent, then you're going a long way to be able to accelerate the implementation of electric vehicles. And electric vehicles are undoubtedly now accepted as an essential element of reducing not just pollution in cities, but allowing us to accelerate our action against climate change. But smart grids and smart energy is a hugely complex beast. I don't want to oversimplify what we're talking about here. I know if you talk to people in many of the telecoms vendors, the big telecoms vendors like Nokia and others, they believe building out intelligence at a level that's required across energy systems that are such ubiquitous beasts is a bigger undertaking than the build of the original telecoms copper networks that were built in the 20th century. They have to enable so many diverse and complex analytics and data management systems that it is not something that's going to happen overnight. But we can cherry pick and ensure that our investment is targeted at the right and most effective places. And one of those is making us capable, not just as individuals but as communities, of decarbonising how we use energy, not just electricity but gas as well. And that's the real objective. Because if we can do that, then undoubtedly we're going to see huge gains in our reduction of carbon emissions. Energy efficiency, E.ON was quoted a few weeks ago, can reduce, and this is just basically looking at consumers and businesses in London and helping them use their energy more efficiently, could reduce the energy consumption of London by 30%. And that's a huge, huge amount. And the benefits that would have on our action against climate change would be considerable. And some countries like Japan have been, for many years now, proactively working to make all their energy systems more efficient by setting standards for products, consumer products in the main, in terms of how they use energy. And we're benefiting. You will know that many of the products now from Southeast Asia are much more energy efficient than they were a few years ago. And it's all down to, initially, the Top Runner program in Japan, where whoever came out with a capability for a more efficient washing machine, that would be adopted as the standard. And all the other manufacturers had to get in line within a certain period, or otherwise they couldn't sell their product. And that has had a huge effect. And finally, EVs are being adopted by governments in a very proactive fashion. This was only last week, the announcement from the States about the construction of a national EV charging network, fast charging network. And we're seeing countries now coming out and stating that they're going to ban diesel and petrol cars from a certain date. The UK said 2040, some EU countries said 2030. But the impact of electric vehicles and electrification of transport will be as big, at least as big, as the electrification of the energy value chain. But it's this localization of energy, the distributed energy, the energy at the end of the networks where normally it was previously only consumed, which could have the really major effect on how energy is used for the rest of this decade and beyond. And it's been termed microgrids, but really it's more than that now. It's localized energy. And basically what we're talking about is community energy schemes, neighbourhood energy schemes, looking at how they are being charged for energy, and where possible employing batteries in EVs, but also potentially batteries in the garage that will, like the Tesla Powerwall, and in the end combining how those devices can come together and optimally work to become, in some cases, even independent from the grid. And many studies now are showing that the cost to us all of employing our own energy usage in a more effective way, together with some of these new innovative products, will produce energy at much lower cost, and a much lower cost in terms of carbon emissions than can possibly be achieved through employing the old model of centralised generation. But the thing that will tip us over the edge into that capability of localised distributed generation and a democratisation of energy is the upcoming data age. It's the impact of AI and machine learning and other data innovations that is going to allow us to make this thing happen in a realistic timescale. IoT, M2M, big data. I'm not going to try and explain all these things in great detail tonight, but what I can tell you is that it's already impacting every day. I meet a new company that is coming up with a new capability to utilise data, exploit data, draw data from the system that is now being built, the smart energy system, to accelerate how we can utilise energy more efficiently. And because the smart grid is about real-time control, about real-time analytics, it's going to require these new data technologies to be exploited to the full if we're going to be able to achieve our goals. And it will be a mix of network services and network technologies. I'm not trying to sell any particular technology here. It will be a patchwork quilt, if you will, of technologies that will be employed. But many of these now are being developed by small, innovative companies around the world. I'll touch on a couple of those in a minute. But it's no longer the domain of the big technology companies in terms of communications, at least, that we're going to have to rely on. Some of the industries have already begun to adopt these new digitalization technologies, and they've been able to realize huge benefits in terms of operating efficiencies, but very importantly, decarbonisation and more efficient use of energy. And where we are now is we're about at the second level, trade and mobility. The big next step will be health, and that it's beginning to make an inroad in certain areas. I'll touch on one in a moment, in terms of how digital technologies are being applied in the health sector. Energy is at the bottom, only because it is the biggest network, the most complex network, but we're beginning to see the first applications in that area as well. And the growth of data availability and the growth of data analytics is mind-boggling. If you look at where we are today, okay, that's 2015, but we're already 3 times ahead of where we were in 2012, only 5 years, in terms of data generation, and we've not even begun the process. But what this does mean is that the large data companies like Google, like Amazon and others, are beginning to impact not just energy, but transport, healthcare. They're beginning to become the if you like, the people at the touchstones in terms of how these technologies are going to be applied and how those industries will be operated in the very near future. In fact, Google, I won't name names, but I had a meeting with an energy utility here about 6 months ago, I think it was, and told that utility, that UK utility, that within 5 days they could take over their whole business seamlessly. And I can tell you the shockwaves from that meeting reverberated around the industry for some time. But that's a sort of test of how powerful and strong these companies are now in relation to industry and society as a whole. If you look at Google in particular, and I won't touch on the others, I'll just mention Google. Google acquired a company called DeepMind, a UK-based data analytics company, about a year and a half ago. I think they paid $500 million for it. The company had never generated a pound or a dollar in revenue. They wanted their brains and their capabilities and their research. And what they did was they turned around that application and demonstrated that by using data analytics and AI, artificial intelligence, they were able to apply that technology to something called Go. It's a Chinese game, which is an order of magnitude much more complex than chess. And within months, that technology had beaten the grandmaster of Go. Now, that's a story in its own right, and it's been written about many, many times. But the important thing is that they then developed another generation of that software within only a few months. That software, the original software had been programmed by people who had analysed the game and taught it how to play it. The second generation, AlphaGo Zero, was allowed to learn the game on its own with no help from the people who designed it. It learned the game in 4 weeks. Within a few months, it had beaten the original software program, and it had taught itself. Now, what that tells the industry as a whole is that AI is here. It's in its very early stages, but once software like that can be designed and can learn problems and how to solve them on their own, then that is a watershed moment. And these applications are now companies like Amazon, for example, are moving into healthcare. In this particular case, this was from last week, and are building healthcare businesses from the bottom up. And a lot of those businesses will be based around the software programs that have been used in their core business previously and the applications that have been used in their core business. Because the AI and the MTM applications can be now applied to any problem that you wish, well, almost, that you wish to address. Sorry, excuse me 1 second. How are we doing for time? Okay. So I'm going to flick through the next. This Siemens is the partner, one of the partners that we've signed up with Send, and I'm very pleased to say that they're one of the leading companies in the field of smart energy and how data is applied. And this is one of the reasons Siemens very cannily partnered with Amazon Web Services very recently, because Amazon Web Services and the cloud capabilities and the computing capabilities that they can offer will now allow Siemens to move into the field of how data and analytics and AI are applied to the energy space. And this will be huge when you see companies like Siemens, who were basically, back in the day, pure big chunky iron companies. They built substations and power stations, and that was it. Now they're realizing that the future of energy is data and information. And this is another example. This is a company in Switzerland who have designed something called swarm technology. And basically, it's the capability for smart meters and appliances in your home to network with your next door neighbour's meter and appliances and ensure that the local grid is optimised for consumers and for decarbonisation. And this is applying AI technology and M2M technology in very low-cost consumer devices. They're also deploying batteries. That's the red box there. So that at times of the day when you're generating electricity and you're not using everything that you might need, perhaps from your electric vehicle, then it stores the electricity so you can access it at a more opportune time. Robotics are converting. As you probably know, Amazon has about 80,000 robots working in their warehouses and very few human beings. These huge, vast consumer warehouses that ships products all over the world are primarily run by robots. And you apply the information age and these data AI capabilities together with robots and artificial processing means like this. And it's not just the energy value change that will change dramatically over the next few years. I'm going to let this run twice. What this is showing you is the view of computing capability in the world over a given time. And if you look at what it is saying, it is basically saying that in the course of the next decade, maybe 2 decades, the potential computing capabilities of the world as a whole will allow us to leapfrog where we are today. And this is even taken into account the advances we're making in data and AI today. But the huge advances that we might make over the next decade with the advance of that computing capability based on Amazon and Google and Facebook's cloud computing capabilities is well, for me, a professor in practice is difficult to grasp. Okay, a couple of slides on Kiel and the SEND project. I have to say, and this is not an over-exaggeration, the Kiel SEND project is a unique opportunity and a unique project in Europe. This is the capability for us to demonstrate everything that I've talked to you about so far today, both in terms of decarbonisation of the energy value chain, but also how we can exploit these new data-based systems and capabilities to accelerate our ambitions in terms of battling climate change. And it's based on the fact that Kiel has, in effect, a demographic and a topology that replicates that of a small town. And we'll be able to do things here that it's very difficult for operational power companies to do in the field with real customers who are paying them to keep energy and utility systems running in the way they've contracted to. And in that integrated form, we'll be able to test out many social engineering issues and many issues over and above just technology issues that again will impact how to embrace these technologies in the most effective way. It's so exciting. And these are some of the operational targets that we've set ourselves behind that project. So not just is it a huge teaching, learning and research possibility, but there's some practical decarbonisation goals that we've set ourselves as well. Okay, in conclusion, what's next for the UK, and can I answer the question that I posted at the very beginning? Costs of renewable energy are falling like a stone, and have been doing now for the last few years. If you look at where the cost per megawatt hour of fossil fuel-based generation is today, and I'll come back to that in a moment, then solar and wind energy is now already below the cost of the fossil fuel plants that have been in operation for 20, 30 years. So building a brand new offshore wind farm or large-scale solar plant or distributed energy system, as I've described, is now lower cost than the operating cost of plants that have been running for 20 or more years. That is a phenomenal achievement and one that we couldn't have forecast even 5 years ago. In Chile last year, $34 per megawatt hour. In Saudi Arabia, $20 per megawatt hour. And we're seeing similar cost projections for offshore wind here in the UK. In the UK, the government has finally published its clean growth strategy. And finally, we're beginning to see the turn in the road where we're accepting that society as a whole, and energy being the central part of that, central pillar, is now got to be based upon an objective of decarbonisation and sustainability. Dieter Helm was asked to publish, to investigate how we should affect this change and how we should move to a sustainable economy. He published a report late last year. Local network and services, the capability for us all to generate our own energy, was central to his recommendation. Yes, we need offshore wind. Yes, we need some centralised renewable-based plant. But the future is all about how we use energy and manage our own energy futures. DSO is Distributed Service Operator. And basically we're waiting for the government to announce how they will allow us to implement distributed or community-based service operators of energy systems. And if that is done in the right way, it will be the turning point for the whole UK economy, particularly in energy. And the NIC, the National Infrastructure Commission, has also published late last year saying very similar things. And when you have the Daily Telegraph coming out and saying exactly the same, then maybe it's real and it is actually going to happen. The other good news is that major financial institutions are all divesting from oil and coal. They're all saying to themselves, okay, hands up, we believe you, this is real, we now need to get out. The cost of coal means the industry will come to a close in nearly every corner of the world. And now we're seeing even countries like Norway, one of the biggest sovereign wealth investment groups, saying that, yes, we're going to divest from oil and coal. So this is the good news. And those funds will now be investing directly in renewable and distributed energy. So the digital energy revolution, can it save our climate from the precipice? If we look at our smart metering initiative and the 20 billion we're spending there and try and re-engineer it and make it more effective to help us embrace local energy opportunities, then yes, potentially. If we design our smart grid, smart energy communications and data system now in advance of deploying these technologies, which we did not do in the case of the smart metering rollout, then yes, we do have a chance. If we review the huge cost at Hinkley Point, look at the cost that we have told EDF we will pay £92, let's say $140 per megawatt hour, when in Saudi Arabia they're paying $20 per megawatt hour for solar energy. Now, obviously you can't draw direct comparisons, but that is a price that is above already the cost of building a brand new offshore wind farm. And the local DSO role, if we can build from the bottom up a decarbonised energy system, one that allows us to share our energy as prosumers with each other, I honestly believe we can turn our energy systems into a sustainable one that much more quicker. What is missing today? Regulatory political will, number 1, 2 and 3, that is the issue. Local energy incentives, we had that FIT scheme and everybody started putting solar panels on the roof. We need something like that for distributed energy to drive, bringing in batteries into our homes, e-vehicles onto the roads. Data networks and security strategy. We need to design our data networks with cybersecurity strategies to ensure that we're all protected. And of course, we need lots of money. But we are spending lots of money already, and we can redirect some of that. Again, that will help us move that much more quickly. So in conclusion, I think the answer is yes. Thank you very much.